Hello and welcome. I'm Miraj and you are watching Tech It Out. Space. It has fascinated humans since time immemorial. We've looked up at the skies and wondered what lies out there. Astronomers have tried to figure out what lies in the far reaches of the ever-expanding universe. Existentialists and philosophers have thought about, well, who are we and what is our place amongst all things? But getting there literally has not gotten much easier. To escape Earth's gravitational pull requires a great deal of fuel, it requires equipment, infrastructure, and what have you. Technology is giving us a helping hand. This week, we're looking at an ingenious company that is mating rockets to high-altitude balloons to make the entire process of getting to space a little bit easier. We'll look at a very dystopian scenario of quadruped robots patrolling Atlanta apartment complexes. We'll check out the very first flight of the world's largest electric airplane. And finally, we'll check out a vocational school, a finishing school, you guessed it, for robots. All that and more coming up in this episode of Tech It Out. High-altitude weather balloons. They are not new. They've been around for ages. Geologists and scientists have used them to gather important scientific data from the upper reaches of the atmosphere. And if you remember, a few high-altitude balloons were in the news a couple of years back when these Chinese balloons were going across the American airspace and they were shot down by the US. But that's another story for another time. This story has to do with this ingenious company that is mating rockets to these high-altitude balloons, using the balloons to hoist the rockets to the very edge of the stratosphere and then firing the rockets. The result is that the rockets need much less fuel and it's much more efficient to get to space. Why didn't somebody think of that before?
Getting a satellite into space usually means using a rocket, and that can be very expensive. Now, a UK-Spanish startup is trying a different approach using a giant balloon. B2 Space uses stratospheric balloons to carry satellites and rockets high into the sky to the edge of space. The idea is simple. Take the rocket up first, then fire it from high altitude to reach orbit. B2 Space calls one part of its approach near space testing. Instead of sending a satellite all the way into orbit just to see if it works, the balloon takes it to high altitude, where it can experience conditions similar to those it will face in space. That includes very low air pressure, high levels of ultraviolet radiation, and extreme temperatures. The aim is to find problems before the satellite actually reaches orbit.
Today, a lot of satellites fail on the first days of their missions in space, so we are helping our customers reduce that risk.
But the balloon is not just a testing platform. B2 Space also offers launches with what it calls a raccoon, a combination of a rocket and a balloon. The balloon lifts the rocket to around 35 kilometers above Earth, above more than 99.9% of the atmosphere. Only then does the rocket fire. The company plans to use a 3-stage solid fuel rocket to carry small satellites into low Earth orbit at altitudes between roughly 200 and 1,000 kilometers. The advantage? The rocket does not have to fight its way through the densest part of the atmosphere from ground level. And that could mean less rocket and potentially lower launch costs. The same high-altitude technology can also be used to test what happens when hardware comes back down. B2 Space says its balloons can carry payloads ranging from a few kilograms to several tons, including drop tests of up to 10 tons from the stratosphere. That could allow companies to test re-entry systems without putting them through a full orbital mission. And the scale of these balloons is significant. The company says its larger systems could even carry something as heavy as a car. Then, there is another use for the same high-altitude technology. B2 Space is developing high-altitude pseudo-satellites. These platforms operate above around 18 kilometers, sitting between satellites in space and drones closer to the ground. A satellite can pass over a location and capture a snapshot, but a high-altitude pseudo-satellite platform can stay over the same area for much longer. That opens the door to continuous high-definition monitoring, including real-time video.
For example, if we are monitoring a wildfire, we can provide live actionable information to their emergency responders so they can see in real time how the situation is evolving. So we're a perfect complement to drones that also can provide information but of a small area because they are flying very low. So we are basically complementing both of them.
And that could make high-altitude pseudo-satellites useful in places where both satellites and drones have limitations. For example, maritime surveillance across large areas, emergency communications when ground networks go down, or backup connectivity during a crisis. The big idea here is not to replace rockets, satellites, or drones, but to connect their capabilities. A balloon can take hardware high into the atmosphere. A rocket can then take a small payload the rest of the way to the orbit. And a high-altitude pseudo-satellite platform can stay in the stratosphere, watching, communicating, and collecting data. For a space industry looking for cheaper launches, more testing, and longer-lasting connectivity, the route to space may not always start with a rocket on the ground. Sometimes it could start with a balloon.
Okay, this story is straight out of some dystopian sci-fi flick. Actually, it's just like Terminator. So imagine this, you're an intruder and you are trying to break into some highly fortified complex and you are set upon by these ferocious robot dogs. Now that's already happening in some apartment complexes in Atlanta, but obviously I'm dramatizing it more than a wee bit. These dogs are still, well, they can't think, so they are manned. There are human beings on the other end who are watching through the dog's eyes and they will talk to you. And yes, they can't bite, but they will call the cops on you. So beware of robot dog, folks.
At an Atlanta apartment complex, the night shift no longer starts with a security guard walking through the parking lot. It starts with two four-legged robots. In southwest Atlanta, the robots patrol a property with around 200 units. The machines move through parking lots, common areas, and other parts of the property that would normally require an overnight security patrol. The system is operated by Atlanta-based startup Undaunted. But these robots are not left to make security decisions on their own. Human operators remotely control the machines while monitoring live camera feeds. And when the robot encounters someone on the property, the operator can speak to them directly through speakers built into the robot.
Hey, this is Landon with Undaunted Products. How can I help you today?
We were having some issues with the security team before that. They were, at the end of the day, they're human beings like we are. So they were feeling afraid or scared to even walk at some groups that would gather in the parking lot where they shouldn't be. So with the robot, that changed completely because it's just a robot. So the robot just goes, asks them to leave. If they don't leave, they call the police or they get me their information so we can send police violations.
The idea is to put a human operator behind a machine that can move around the property instead of having that person physically present there. The robot can patrol throughout the night, while its cameras provide the remote operator with a live view of what is happening on the ground. It also uses artificial intelligence-powered camera systems to help identify activity that may require attention. That creates a different security model. Instead of waiting for a security guard to discover a problem during a patrol, the system is designed to keep watch continuously and allow an operator to respond from a remote location.
These dogs are managed and controlled by somebody behind a screen. It's not AI. Nothing with AI on these dogs. It's literally a walking camera. Somebody else is behind the robot, controlling the robot, talking to the residents over that camera. So it really feels very personal. It really feels very one-to-one.
The robot can approach people, ask them to leave, and allow the remote operator to communicate with them. If the situation escalates, the operator can contact police or property management. For residents, the robot has also become part of the nighttime routine. It greets people as it moves around the complex and continues its patrols through areas where residents park, walk, and gather.
Well, I know that they're like security, and I think it's really cool that people created a robot to be security.
The robot combines mobility, cameras, remote human control, and AI-assisted monitoring in a single system. The system has also helped the property address security incidents without putting a human operator directly in front of a potentially difficult situation. And that is the shift that technology brings, from a robot that simply watches to a system that can move, see, and respond with a human still in control.
This week also saw the successful maiden flight of the X-1 made by Heart Aerospace, an electric aircraft, wingspan 109 feet, It flew for 27 minutes, took one pilot, but the most outstanding statistic of all, consumed only $5 worth of electricity, serving as a test bed for commercial electric aircraft to come. Interesting story, have a look.
What if air travel could use far less fuel and far less energy? That is the idea behind a new aircraft from US company Heart Aerospace. The company recently completed the first test flight of its X-1 demonstrator. A full-size battery electric aircraft designed to test technology for future commercial flights. At more than £25,000, X-1 is now the largest battery electric aircraft to have flown, and this was not a small experimental aircraft. The flight was designed to test electric propulsion at a scale closer to a real airliner. The X-1 took off from Plattsburgh International Airport in New York. The piloted flight lasted 27 minutes with no passengers on board. The aircraft climbed to around 1,100 feet. And during the flight, its all-electric propulsion system delivered more than 1 megawatt of power. The test included taxiing, takeoff, climbing, maneuvering and landing, and there was another number that stood out. The entire flight used just around $5 worth of electricity. That does not mean electric planes will be this cheap to operate overnight, but it shows why aircraft makers are looking at electric propulsion for shorter routes. The bigger challenge is the battery. An aircraft has to carry everything it needs to fly, including the energy that powers it. That is why battery electric flight is currently more suited to smaller aircraft and shorter routes. Heart Aerospace is trying to push that technology further by using X-1 as a test bed for its future commercial aircraft. The company says the aircraft could eventually help reduce operating costs, thanks to lower energy use, simpler electric propulsion and lower maintenance requirements.
If you're trying to introduce a radically new technology like electric propulsion, you need to have a development process that's more iterative. That tightly integrated approach to development is really key because if you take on risk, you learn a lot. That learning process is what drives the technology forwards. And that has to be fast. You can't be waiting for components to come back from a vendor. Can't be working across many team boundaries in order to identify and resolve issues.
The X-1 is not the aircraft Heart plans to put into passenger service. It is a demonstrator for the company's ES-30, a 30-seat hybrid electric regional airliner. Unlike the X-1, the ES-30 will combine electric power with other sources of propulsion, allowing it to fly further than a pure battery electric aircraft. Heart is targeting entry into service in 2031. The company says the ES-30 could cut operating costs by more than 40% compared with older regional aircraft. Airlines including United Airlines and Air Canada have already committed to the aircraft. Electric flight is not the only new approach being tested in aviation. Around the world, companies are also developing eVTOLs, electric aircraft that can take off and land vertically. Their goal is different. Instead of replacing regional airliners, eVTOLs are being designed for short urban and regional journeys, without needing a traditional runway. But both technologies are trying to solve a similar problem. That is, to make short-distance air travel cheaper, cleaner, and more accessible. For Heart, the next step is already underway. The company is building the first pre-production ES-30 at its pilot manufacturing plant in Los Angeles, with flight testing expected to begin in 2028. Aviation is testing different ways to move people without relying entirely on jet fuel. The technology is not ready to replace the jet airliner just yet, but with the X-1 now in the air, the electric airliner has taken another step closer.
A vocational training school for robots. Why am I not surprised? Actually, I'm not even surprised about where this is taking place. In Hangzhou, China, 30 robots are being put through the paces, learning about the arts, sport, music, nursing, training, all kinds of things. But you know, the crazy thing is, there's a fundamental difference between training a robot and training a human being. Now, if you're a human being, each and every one of you has to go through the vocational training. But if you're a robot, machine learning to the rescue. If I have the same software and hardware as another robot, then if I learn it, then that knowledge simply gets passed on to the next and the next and the next. Unbelievable.
The robot school is where we train humanoid robots from the ground up. Think of it as a complete journey, starting with the very basics of the robot body and hardware, then moving on to its core systems and intelligence, and finally teaching it specific skills, like how to appreciate and create art.
In China, a new kind of school has opened and its students are robots. They are not there to learn basic movements, they are being trained for real-world jobs. In Hangzhou, in Zhejiang province, the Hangzhou Robot School has started training its first group of 30 robots. The robots come from different fields, including manufacturing, services, security, and entertainment. And the training is designed to take them from basic assessments to practical skills. The robots are first assessed physically, then they move into different courses and training areas depending on what they are designed to do. The school has 4 main areas of training covering technical skills, nursing, arts, and sports. And the difference between these robot students is easy to see. Some are being tested in industrial tasks, others are learning how to interact with people, and some are being trained for activities that are far less industrial. Robots learn to play musical instruments, take part in sports, and even make coffee. One robot, Wuji, is also being used as a tour guide around the school. That means the training is not limited to what happens inside a factory. The school is trying to prepare robots for different environments where they may eventually be expected to work.
This training program is also tailored to the specific requirements of different robot hardware and manufacturers. While we offer distinct training plans, we also provide a core curriculum of common courses. For example, Dean Zhu of the Zhejiang University Robot Research Institute proposed a system featuring VLLA and WJ Brain. This system equips robots with the underlying logic needed to understand the real world.
Engineers also test the machines while they train. They check their movements, work on their code, and track how they perform different tasks. In one training exercise, a robot is learning to pick up objects, stack them, and move them to an assembly line. After that, it can move on to more precise tasks. And as the technology changes, the training can change with it. Robots can return for refresher courses and learn new skills to match their future applications.
Some robot hardware and components are already highly capable, yet they still struggle to adapt to actual application scenarios. At our robot school, our main goal is to empower the robot's brain, enabling it to successfully transition into the workforce.
The challenge is not just to build a robot that can walk or move its arms. It is to make that robot useful when it is put into a real-world situation. That is where the robot school comes in. It brings together the robot, its software, and the training needed to turn its capabilities into practical skills. The school currently has 30 robot students, with plans to reach around 200 to 300 over the next 2 to 3 years. And there is an interesting part to this kind of education. When one robot learns a skill, the training can be replicated across other robots with the same hardware baseline. So the classroom may start with just one robot learning a task, but the lesson does not have to stay with that one machine. And that could be the bigger purpose of this school. Not just teaching robots how to perform tasks, but building a system where those skills can be repeated, updated, and put to work.
Peculiar story, that robot school, isn't it? Even as somebody who's majorly into tech, sometimes, the truth is getting so bizarre that sometimes I don't know how to react to these stories. And the one thing that I did think about was, well, robots can clearly learn very well. You teach one, you teach them all, right? Humans have a much harder job. How do we interact with robots? Because they are definitely coming. I, for one, have zero savoir-faire when it comes to how to deal with a robot. I'm going to leave you on that note. Have a great weekend. Keep watching WION. We shall see you in the next episode of Tech It Out. Bye-bye.